Hey everyone, we're going to evaluate the integral of x to the power of 4 plus 1 divided by x times x squared plus 1 squared dx. Alright, so the way we're going to set it up is write it like this. For partial fraction decomposition, this would be a divided by x, and then we have two of these repeating irreducible quadratic factors. So that's going to be bx plus c divided by x squared plus 1. Or when we're just trying to get all the options we have when we decompose this. And then we could have just the d and the e here. All right. And then when you clear the fractions by multiplying through by your least common denominator, you're going to get x to the power of 4 plus 1 equals a times x squared plus 1 squared. And then for the bx plus c, we're missing an x and we're missing another x squared plus 1. And then for the dx plus e, you're going to get, we're missing these, just the x, so that's going to be x. All right, so if you let x equal 0, these two will cancel out. And that's going to give you 0 here is going to give you 1 equals a for this one. So a is 1. Now let's equate the equations for the coefficients of x to the power of 4. Let's see, this is going to be x to the power of 4, so that's going to be 1 equals a. This one's going to be plus b, and this one doesn't have it. So basically all I'm doing is multiplying my x's. So this would be to the power of 4, x to the power of 4. And that means if a is 1, then that means b is 0. So what's going to happen, I'm going to do that now. This is going to go away. If b is 0, this is going to go away, and we just have c. My a is going to be 1. All right, so this is what we have. Now, let's go ahead and rewrite this. We have c divided by x squared plus 1 plus dx plus e divided by x squared plus 1 squared equals x to the power of 4 plus 1 divided by x times x squared plus 1 squared. And I'm going to subtract this from both sides. So minus 1 divided by x. Now what I'm going to do here is, and I'm going to squeeze it in, I'm going to pull out 1 divided by x. I'm going to factor this x out here. All right. Also, I'm going to get my common denominator. So if I want my common denominator to be x squared plus 1 squared, then I have to multiply this numerator also by that. If I expand that, that's going to be x squared plus 2x plus 1. So basically what you're going to get is x to the power of 4 plus 1 minus x to the power of 4 plus 2x squared plus 1. All right, so that's just factoring out the 1 divided by x. Now what's going to happen here is you're going to get the x to the power of 4 is going to cancel. The 1's will cancel. And you're going to have, I'm going to stick it here, 2x squared divided by this x here. So that's going to, and it's still negative, negative. So basically you're going to get negative 2x divided by this. All right, so let's write that down. So you're going to get negative 2x divided by x squared plus 1 squared. And that's going to equal our c divided by x squared plus 1 plus dx plus e divided by x squared plus 1 squared. All right, you can let c has no x here. So if you equate coefficients, our c is going to be 0. Our d here is going to be -2. And our e, there's nothing here. So e is going to also equal 0. Therefore, what we're going to be left with, if c is 0, this just goes away. Our d is -2. So basically, we can write our integral now as the integral of, we had that 1 divided by x, all right, minus, and with all these zeros, all you're left with is 2x divided by x squared plus 1 squared. All right, dx. Now, so when you integrate this, this is going to be ln of absolute value of x. And this piece right here is just going to be plus 1 divided by x squared plus 1 plus c. Because if you let u equal x squared plus 1, then you get du equals 2x dx. And then when you do your substitution, you'll get this out. Because you have your 2x dx. So this would just be that. Thank you. Have a nice day. Bye-bye.